This video shows how to use the design tool built into the HinksPix controller to quickly and easily configure your controller for your display. Now, one of the first and most important steps in any configuration is you must have completed your design. And the design means that you know where every single control box is going to go or receiver and where each cable coming out of each of those boxes or receivers is going to connect to. So if you have a megatree, you need to know how many pixels and how many outputs of those are going to be used with those number of pixels. So in this particular case, we've done that. We've got a design here, and we have 3 props. This is a common use, and in this particular case, we're going to use a main controller with long-range expansion capabilities that has a HinksPix Pro CPU, one long-range receiver to handle the star that has 270 pixels, the tree that has 16 strings of 50 pixels, and finally a long-range smart receiver for 4 arches, each with one cable connected to each of the 4 outputs. Now let's look at that physical control box. Now this example shows a different CPU, but if this was the HinksPix Pro, this would apply. Now this example will use this exact configuration, and what we're concerned about here is these boards at the bottom. These boards at the bottom here are the long-range receiver outputs. So these are the expansion outputs that go to your long-range smart receivers. Or if you have a regular receiver, it will also go there too. Then we have the localized 16 SPIs. So these are cables directly connected. So in this particular example, these normally are red in color, and these come out and go to a receiver. An example is shown here. This is a long-range smart receiver indicated by the fact that it has red jacks and it has an input on the left and 2 outputs. Now in our example, this particular video shows only one output to one receiver. It is possible for this product to be daisy-chained or split using these additional jacks. We will not be showing that in this particular video. If you have an advanced configuration, please see those other videos. Now, what we have is we have our input. It goes right here, and we have our 4 cables coming out. Those have power plus data. One other item of note is that the red block at the top is the address. There is a chart to the right that says how to set it. And in this particular case, we're going to set all of our switches in off or down to make the address of this receiver 0. We'll do that on both receivers. So we have 2 of these receiver boxes, one for the megatree using output 1, then one receiver box using all 4 outputs going to each of the arches, and the 16 outputs going directly to the tree. Now, let's look at what that looks like further upstream in X-Lights. Now, I'm going to show X-Lights in this example since this is the most popular program used for holiday lighting control. But if you're using LOR or you're using other types of software, this will apply. You simply just need to set up your DMX universes appropriately. So here's the same setup. Here are our props, our star, 270 pixels. It has right here, you can see 270 pixels, one string. We have a tree that is comprised of 16 strings and 50 pixels. And then we have arches each, which have 100 pixels and one output is used per arch. Okay, so let's get started with our project now that we've defined what we're doing. Again, the key here, you must 100% absolutely know what you're building. All right, first let me explain that we're going to use something called configurations. They're basically profiles. So if we go up here to the MISC settings and go to manage controller configurations, you're going to see that we can configure different profiles. And if we click this drop down, you can see them. Now, one thing to note here is that you do need an SD card installed into the controller's SD slot. This will not save your configuration if you do not have that configuration selected. So you need to have an SD card installed to use the design tool and to save configurations. Now, why would you need more than one configuration. You might be testing, you might build something and then try something different, or you might have a different season. You might have Christmas and then you have July 4th and you have totally different configurations for those. And this allows you to easily load them up, load them in the controller, and immediately execute them without losing any data. All right, so first step here is we want to go ahead and go to the Design tab. Now, by the way, if this screen doesn't look familiar at all and you don't see this, you may need to back up and go to our videos on configuring your controller to connect to this web interface. This is just a web browser connected to the controller. All right, so next thing we're going to do here is we're just going to go ahead and give it a name. So we're going to call it Test 3. Now what we're going to do is we're going to tell this configuration what we have. Now you might think, oh, hey, it knows what we have. And it does. It knows you have 16 SPIs on the second board, and it knows you have a long-range expansion board. But it doesn't know what's connected to this long-range expansion board. And also, you may want to be able to save configurations that don't even match this physical configuration. So we need to first tell it what we're going to do. So we have to tell it what driver boards or expansion boards are connected to this HinksPix. So in this particular case, let's go back and look at our physical picture. We have a long-range expansion board, one of those, and right below it we have the 16 outputs. Now I should mention that boards are always numbered from top to bottom. So this is 1 through 16. This is 17 through 32 and 33 through 48 if there was an additional board below that. You'll see that these correspond to these cables up here. So the back plug, it goes to the bottom board directly below the CPU. That's 1 through 16, 17 through 33, and 33 through 48. So you can see that this jack is not utilized, thus we don't have a third board. So let's go ahead and check those off. So we have a long range. And you'll notice that when I've clicked this long range, some other stuff appeared. So it appears right here. I check this off and it says long range board 1 assignments, and then it has active Cat 5s. Now I'm just going to for information, click off long range 2. You'll now see that it has additional boxes here. But it only still has one of these active outputs. Now, why does this say 1 through 16? Now, cat means category 5. It's the name of the cable. You can just assume cat means cable. So why do we have 12? Because we could have actually up to 12. So if we had 3 times, we got 3 individual expansion boards times 4, you could see how we could get to 12. We're not doing that. We are going to have one board, and it's going to be much easier. Now, we also have an SPI board below that, and this does match. Long range 1, 16 SPI, right? And if we go up here, long range 1 through 16, SPI 17 through 32. Now, the first thing we need to do is also go over here. We need to say long range is connected to 1 through 16, right? 1 through 16. Then we need to set SPI. You can see SPI ports 17 through 32. We're just going to leave all the other defaults the same. Now, we first need to tell it what we're actually going to map. So we're going to say Cat5 cable 1. And by the way, these match perfectly left to right to our physical design. 1, 2, 3, 4. 1, 2. And we're not using 3 and 4 because in this setup, what we're going to do is you're going to use these green cables, and we're going to use 1 here, number 1, going to this receiver, which goes to the star, and then number 2 will go down here to this receiver controlling the arches. Okay, so now what we need to do is tell it we're actively using those cables. So you can see that I have not selected any cable, not used, not selected. All right. Now, what it has done is it has added this controller show design, and you'll see it's made up of several parts. The first main piece is the strings, and we'll come back to that. Then we also have the actual number of SPI boards or long-range boards that we have connected. And you'll see it says cable 1, cable 2, cable 1, cable 2, cable 1, cable 2. All right, and we're going to come down here and we're going to tell it, because it doesn't know how many receivers. It needs to know how many of these are connected to those Cat5 cables. So we need to tell it we have one connected to this and one connected to number 2. All right, so we're going to say SPI Smart and SPI Smart. Now, if you had a 16 SPI or a Smart 16 AC, you could select those two. See our other videos for more advanced configuration options. Now, when I've added those, you'll notice that it again has that address of board ID 0. And again, this refers back to this little red dip switch. So these should all be off, right, for 0. And we'll see that that actually shows up in another configuration page once we actually load the configuration. Now, there's nothing else in here. These physical ports refer to the actual cables. So 1, 2, 3, 4, right? 1, 2, 3, 4. Those are the physical cables coming out. Now, this is going to be our star, and this is going to be our arches. And then down here, we have our megatree, 16 physical ports. All right, now just to prevent any confusion, it is possible that your controller, depending upon its configuration, because each controller can be completely customized, these physical cables may be labeled 1 through 17, or 1 through 16, 17 through 32, or 33 through 48. And that should not be confused with these physical ports, because the physical ports refer to the actual little numbers that are printed above these ports. So, 1, 2, 3, 4, 5, and so on. So be aware that these cables may not label exactly the same as to your physical thing. Okay, so we've got that. Now, as I said before, the number one step, you've got to know what you're building. So you must have already figured out what connects to every single connection or cable or SPI output on each receiver or controller. And we have done that. So we can now go ahead and start doing this process. So what I'm going to do is I'm going to go ahead and come up here and I'm going to put in the first thing that we're going to connect. That's going to be our megatree star. Now, our megatree star, if we look back in Xlights, remember that it has 270 nodes. So let's first give a little background as to nodes, pixels, channels, and universes. They're all interconnected, and it's important to keep them so that they're completely clear as to what they are. So I'm going to go ahead and open up my calculator. Now, a node is generally a pixel. A node normally is technically a physical description of a type of light, but it's often interchangeably used with the word pixel. And in this particular case, we actually have 270 pixels because we have RGB nodes down here. So what does that mean? It means I have to use 270 pixels. So I take 270 and multiply it times 3. Why 3? We've got red, green, and blue. So for each pixel, each individual light, we've got a red, green, and blue LED inside that pixel or LED pixel. It then needs to be controlled individually. Well, we have 270 pixels. That means we have 270 times 3 channels, red, green, and blue. That's 810 channels. Now, this poses a problem because a universe is only 512 at maximum channels each. And there's some math problems there. So if I take 512 and I divide it by 3, you'll see that I get 170 plus a remainder of 0.6. That's not good. We can't divide a channel into parts or 6/10 of a channel. So we need to get a solid number. So 170 times 3 is actually 510. So almost every vendor in the market uses 510 instead of 512 as the number of channels. And that's what we're going to do here. Okay, but remember, we have 810 channels. What do we do? Well, if we take 810 and minus out 510, we get 300 additional channels. Why does this work? We need to make 510 channels on the first universe, and then on the subsequent sequential number of the universe, we need to put the remaining 300. So it just rolls over. It uses 510 channels, then it rolls over to the next number of pixels, which in this case would be our channels, which would be 300 channels. So let's go ahead and configure that. So we go in here and we need to do this in an order of universe channel. Now I'm just going to start at 1. I'm going to put in 1 colon, and so 1 is the universe, and this is the number of channels, 510. And then I've used up all of the channels that I can, as whole numbers of divisible by 3 in there. So that's 170 pixels. And then I need to put in an additional 100 pixels. So we need 300 channels on universe 2. So I put in 2 colon 300. So 510 plus 300, 810. And that's exactly how many channels we needed. and we just split it across universe 1, then universe 2. Now you may notice that there are actually 4 possible universes. Why is this? So this is because if you've seen limits, you'll see that 512 times 4 universes is 2048. That's how many channels of data you can send to any single output. So for this specific output, you can only send that number of channels, 2048. So if you divide that by by 3, you'll end up with 682. Actually, 680 is the number you'll really use. Okay, so we've got that first one. Now we've got more channels we need to add. So first thing we're going to do is just add some more. Add more strings. So the next thing we need to do is add our arches. And we've got 4 of them, right? So we're going to put 1, 2, 3, 4. There we go. And we'll just go ahead and continue on. Now, there are many different worlds of configuration and the ways you could do this. Some people will start at 1. Some people will start at 101 universes. By the way, there are 65,000 universes. And in any of this configuration, not only within the X lights, but also in the controller, there's many ways to configure it. My method may be the method you choose to use. You may have seen other videos that show you slightly different methods. They're all valid long as they work. Okay, so the next thing I'm going to use is universe 3, and it needs how many channels? It needs, let's go back over here and look at our arches. It needs 100 nodes. So, of course, 100 times 3 is 300 channels that we need. All right, so we're going to put in universe 3, 300 channels. And because that's under 510, right, it's going to be okay. So I'm going to just put that in there. Oops, I'm sorry, here. 3, 3, 3, and then just go ahead and keep sequentially increasing these numbers. So 3, 4, 5, 6. All right. And then, of course, next we have the mega tree. So I'm just going to add some more strings here. And I'm going to do mega tree output. And you might put, in this particular case, this controller likely would have been configured as 17 through 32 with the cable labels actually on the ends. How you label this is really up to you. I'm going to put 17, but it could be number 1. It just depends on your setup. Now, because this is going to take a moment, I'm going to go ahead and complete this, but I'm going to do the first one to show you. And how many pixels do we need? We need 50 pixels. So here we go. Our mega tree has 50 pixels on each of the 16 outputs. So let's go ahead and go up here and do universe 7, our next one, and put in 150. So 50 times 3 is 150. I'm going to go ahead and pause the video, and I'm going to go ahead and configure all outputs 17 through 32, which is that, again, outputs right here onto the HinksPix, and we'll proceed from there. All right, back, and I have now configured all of the outputs 17 through 32. And you can see that we're using a total of, in this case, 23 universes. We've got 21 here, and then we've got an extra one over here. Now, just a word of on a side note here. Sometimes if you have a very complex display, this display shown here is not too complex, but if you had dozens of elements, sometimes people do find it easier to create a spreadsheet and map out everything. They put in their controller number, if you're going to put a box number on each one, and they put in what's physically connected to each cable, how many pixels. They even go really extreme and put in how many watts and all that, the percentage of output. So there's a lot of documentation you can do, and that often helps you do your configuration out in the yard. So you go out there, box 1, output 1, star 270 pixels on whatever. Okay, so now we've got our physical things down here, but the problem is that we've just defined all these universes and channels and all that kind of business. But the problem is it doesn't know where they're linked together. So we have to link them together. So the first thing I'm going to do is go down here. Now this is our receiver. This is this item right here. And we're going to use output number 1. And output 1 is going to be connected to the star. Now I'm going to click in here. I'm going to say physical port. That's SPI, the labeled cable number 1. And it turns green. It turns green, and I go up here and I click star. And look at that. It puts the star in here. And I'm not going to use 2, 3, and 4 in this particular case. We're not going to utilize it. I'm going to pick down here. Now this is our cable 2, and this is our smart receiver again, and that's plugged into cable 2 right here. And I am now going to then map that to my arches. So I'm going to do 1, and then I'm going to do 2, 3, and there's going to be a beep each time you do this, and you can see they're mapped. And I'm also going to do the first output of the megatree here. So I'm going to come down here to the SPI, and I'm going to go up here and click the first one, and you can see that that one is mapped. I'm going to go ahead and finish these up for the megatree. All right, I'm back, and we can now see that we have all of these outputs configured properly. 17 through 32 is mapped out to here to the physical ports. We have our arches and our tree, our megatree star. Now, what we're going to first do is do some checking. We're going to do some sanity check to make sure there's nothing wrong. The tool has some built-in logic to help you figure out if there's anything not configured that's physically possible. So I'm going to click sanity check strings. And that's great. String valid is data. But what if it's not okay? Now, by the way, when I entered that, you'll see that it automatically put the total channel count in here. I'm going to make a mistake. I'm going to make a mistake by putting in 810 channels like this. Now remember, we can't put 810 channels on a single universe. Let's check it. There we go. String universe 1 outside the range. It's between 1 and 512. It knows this number can't be more than 512, and that's correct. So again, we're going to change it back to 510. Go over here, put universe 2, and put 300 channels. Do a check again. All good. Okay, so that's good. Now what we need to do is just check the overall complete design. And to do that, we perform a design check. So I'm going to go ahead and say, great. Now it comes back okay. Now if it came back with an error, you could have an issue where you've assigned too many pixels. The most common reason is that you may have multiple long-range receivers all connected on one single Cat5 cable, and you may have used up the number of pixels possible, 680 pixels times 4, or 2048, I believe. Okay, so everything is good here. We are all set. So I'm going to say save the design name, and I'm going to go ahead and save it to the SD card based on this particular design. And you can see that it says it has been saved. Now, what I'm going to do is go ahead and go to Miscellaneous Settings, Manage Configurations, and remember ours is 3. So we're going to go ahead and say Test 3. I'm going to say Install. And what this is going to do is it's going to go ahead and configure all of our data on our tabs up here for proper configuration. It's going to go ahead and click OK. Now it's saying I have to reset, so I go up here to Reset, and I click the Reset button. I'll be back with you once that's reset. All right, we've rebooted now, and let's just check to make sure our settings are now in there. So we go to the E131 tab, and we see that we have 22 universes, right? So you can see that they're right. 510, 300, that makes up our star. 300, 300, 300, 300 are our arches, and 150 is all of the tree's outputs. Okay, now if we go up and look at the actual output settings, you can see that it's even already configured that. We see 270 pixels. Now, just a word of caution here, not to confuse these start channels you may see here. These are controller start channels or controller in channel. These are used internally, and you'll notice that they're above this number. These are used to map. So what's happening here is that we've moved channels internally within the controller 1 through 810. Over here, we go to the E131 tab, and you can see 1 through 810 is assigned over here. But what we're really just trying to do is get these to a universal number called a universe number, and that's what we've got here. All right, now what we need to do is we need to take this configuration and map it into X-Lights. So let's go ahead and go there. So we're going to go into X-Lights, and we're going to go to the Controllers tab, and we need to add a controller. So I'm going to say Add Ethernet. I'm just going to give it a name like Test3, and you could just, give it whatever you want. And you could also select the vendor, HinksPix Pro. Now, you may see some options down here for upload, input, output. I don't recommend using these unless you're familiar with what you're doing. Don't select multicast, enter the IP address. Now that IP address is over here. It's right up here at the top. This is where we're going to be sending our data. All right. And we're going to use the E131 protocol. We're just going to leave this the same. We set it start universe 1. Now in this particular case, we are starting at universe 1. You can see universe number right here, and you can see that it is 1. And we have 22 total universes. So let's go ahead and just configure that. 22 universes. So how many universes? 22. And I'm going to put in here that we're doing 150. I know that's not correct, but we're going to change that by clicking this box, individual sizes. That then creates this little button here. And you'll notice that we have 22 universes. So this is universe 1 through 22 because we said start at 1 and we said we have 22 universes. And so what we need to do is just make this match up with this. So we have 510, then we have 300, then we have 300. So that's the first arch. This is the second arch. And this is the third arch, and finally the fourth arch. Now, at universe 7, we start with 150 channels. So let's go back over here and look at that. So universe 7, you can see we start at 150 channels, and we go all the way down here. So that probably explains why I put in 150, so I wouldn't have to retype these 150 since that's the predominant number. Okay, so now we have all of these configured, and I'm going to click Save. And I'm going to go over here to Layout, and now I need to map those universes, which is passing through the controller, and then it's passing over here from this universe into the actual output. So it's the direction it's going. So our star, it starts at, and then we're going to go down here to Start Channel. We're going to click these little 3 buttons over here on the right-hand side. I'm going to say Universe. And you can say the actual controller IP address, but I just choose any. I click OK. And you'll notice that right here it says Start Channel, End Channel. These are universes, and this is Universe 1. So notice how you have that same nomenclature. Universe is on the left, channel, or DMX Universe, channel is on the right. So we start at DMX Universe 1, Channel 1, and we end at Universe 2, 300. Channel 300. Now, you notice how it knows to not use the 2 pixels at the end of the 512? So it goes to 510 and just skips them. It just knows. That's why we always skip over 511 and 512. And it shows, of course, we have 810 pixels, which, of course, perfect. We have 810 pixels on that prop, so everything is good there. Now, by the way, if you're ever trying to figure out what's mapped physically, in terms of channels and whatnot, you can right-click over here, right-click on it, and say Wiring View, and you can see how this prop is wired. And this is outside the scope of this video. Models themselves are a whole separate area of configuration and not related to this configuration. So you do need to configure a prop correctly so that it knows where you have put the pixels, but that's outside the scope of this video. Okay, so the next thing we need to do is we need to select our arch, and we're going to put in, and if we go back and look here, you can see that we start on universe 3 with 300 channels. So we're going to go in, select universe 3, click OK. Now, what will happen is that it has automatically linked these together. Now you'll notice that it said universe 3, channel 1 through universe 3, channel 300. Do you notice how we've linked these together? So we did what's called chaining. Now this is not required. You can be literal by changing this start to a specific number. But you could also say start channel is not the actual universe. It is the last thing. But for simplicity and to ensure clarity, I'm just going to go ahead and force it to very specific universes. And remember how I said that there's many different ways to do everything within Xlights and even in the configuration of the controller. And And so there's no necessarily one right way to do this. Okay, so we start at universe 1, then 2, then go up to our arches, 3, 4, 5, 6, and now we need our tree. So we're going to go here, start channel, and that starts on universe, oops, I keep thinking that, click universe 7, I believe, right? So we end at 6 and we end at 7. So we end with 44,410 channels. Now, again, this is the internal start channel and end channel of the internal controller, but you can see that we've consumed 4,410 channels. So this configuration is now completely good. You just hit save, or you can go up here to save layout and save that configuration. And now what you want to do is to confirm this. Uh, what you can do is first test anything at the controller level. So sometimes if you're having problems, you want to go downstream first. So if we wanted to test the outputs, for example, on our Megatree, we could go here, select all ports, blink them, and that should be causing the Megatree pixels to blink. If we went up here and we selected this and we said port 1 and we said blink white, now the stars should be blinking white. Now we can do that same level of testing, but at a higher level. Now, if we don't have the configuration of the controller working correctly and the test is not working in the controller, it won't work in X-Lights either. But let's go ahead and go to Tools, Test, and you can check by universe, or you can go over here to the models if you want to check by models. So there's a lot of different checks. So you could check this, turn that on, go over here to background, make sure that's selected, select the intensity so that it's high, and now your arch 1 should be on, arch 2, arch 3, or the star, or the tree, and you can test each output. And so that concludes our first initial basic configuration of Long Range Smart on the HinksPix Pro controller.